So we're going to go through an example of how to use the future value formula. So here's our example. So find the amount to which 6,000 will grow if the interest is 10% per year, compounded quarterly for 5 years. So when you're doing these types of problems, your first step really should ask yourself, are you using simple interest or are you using compound interest? So in this case, it says directly in the question, compounded quarterly. So we are using compound interest. So that narrows it down a little bit. And then your next question you should ask yourself is, are you finding your present value, your principal, or are you finding your future value or your maturity value? So in this case, we'd like to know what it will grow into. So the 6,000 really is our present value, our original principal, and we would like to find our future value. So that really sort of narrows it down for us. So we know that we're using compound interest, and we know we want to use the future value formula. So we can take our formula from our resource sheet, remembering future value, present value, I and N we talked about, but they are on your formula sheet a little bit further down too. We have formulas related to them as well. So we know what those values represent, and we can plug those into our formula. So let's start with writing our formula down and then thinking about what we have and what we want to get to. So we'd like to find future value, and the formula for compounded is present value multiplied by 1 plus I, and that whole bracket is to the exponent n. So let's start with what we're given. So we know present value, so original value is $6,000. So that's what we're going to put into invest. And if it grows at an interest of 10% per year, so that is our rate of interest, which is 10%, or remember, we always want to put that into a decimal, 0.10. And it's compounded quarterly. So this is basically the new part we're kind of adding in, is those compound periods, which we've called M. So quarterly is that you're doing it 4 times a year. And then our time frame is for 5 years. So remember, T needs to be in year format, so it is in 5 years. We don't have to do any conversions there. So we've got everything out of the question, but remember we need to calculate our I and our N value. So our formula is I is equal to R divided by M, and our N value is equal to M times T. So R, our rate of interest, is 0.10, all divided by M, which is quarterly. 4 suggests that you leave that in a fractional form. In case that you have decimal places, you don't want to lose that until the end. And then your N value is your M, 4 times 5 years, so you end up getting 20 come out there for your N value. So then it becomes substitution. We have our PV, our present value, we have our I, and we have our N. So 6,000, I always change this one to sort of a square bracket, because sometimes I put in fractions with extra brackets, but you can leave it as is. So 1 plus I, which is 0.10 over 4, so that's my I value, and then that entire bracket is to the exponent n, which in this case is 20. So you do need to make sure that you do whatever's in the bracket first. You can leave it in your calculator as you sort of do the steps along the way. I end up doing, if you do your 0.10 divided by 4 plus 1, you should end up getting 1.025, and that bracket is to the exponent 20. So I always do that, leave it in my calculator, then I hit exponent 20, then I multiply it by 6,000, and in the end you should get 9,831.6986, etc., etc., etc. This is money, so obviously we're going to round it to the nearest cent. So approximately equal to $9,831 and bump 70 cents. So investing 6,000, compounded in this way, we're going to get a future value, or at the end of that time frame, $9,831.70. So if you take your future value formula, just as we've done before, and we actually solve for present value instead, you can have an altered formula. So if you go through the process of actually rearranging that formula, your present value is equivalent to future value divided by 1 plus I, the exponent n. or as we've talked about before, you can make that a negative exponent. So present value is future value multiplied by 1 plus I to the negative n. So this is generally the other version that you see on your resource sheet as well, which is just the manipulated version of that exact same formula. So we have that, notice the negative n versus just to the n. So watch carefully which one you want to solve for.